So here we are with our last lecture of the year, woohoo! And it's the last part of our stoichiometry. So it's limiting and excess reagents, okay? And if you have a little trouble even understanding it after this lecture, you can go to your chemistry book. It's in pages 369 to 371. It's titled Limiting and Excess Reagents, and you can look at examples 12.7 and 12.8. So just to kind of give you a reference over what we're talking about, limiting reactant and excess reactants, we're going to talk about pizzas. So if we use the pizza analogy, to yield one pizza, it's kind of backwards, but to yield one pizza, you need one crust, 5 ounces of sauce, and 2 cups of cheese, okay? And suppose we're sitting here and we're looking at, well, I have 4 crusts, I have 10 cups of cheese, and I have 15 ounces of tomatoes. How many pizzas can I really make from what I have? So we have to look at each of these reactants, the crust, the sauce, and the cheese, and we have to see how much would each make. So if I have 4 crusts, well, I can make, for 1 crust, I get to make 1 pizza. So that'll give me 4 pizzas. For 10 cups of cheese, well, I need 2 cups of cheese for 1 pizza. And if I figure that, that'll make 5 pizzas. And if I start with 15 ounces of sauce, that's my given, and I need 5 ounces of sauce for 1 pizza, that makes 3 pizzas. This right here makes the least amount of pizzas. So my sauce is my limiting reactant. It is the cause of me being able to make only 3 pizzas. When I'm done, I will have no sauce left, but I still will have crust and cheese. Those are my excess reagents, okay? So let's start with a couple definitions. So limiting reactant or reagent is the reactant that is completely consumed. It's all used up. There's not going to be anything less. It's the pizza sauce left. It's the pizza sauce. In a chemical reaction, limits the amount of product. That limited how many pizzas I can make. That 15 ounces of sauce kept me to only 3 pizzas, okay? And it makes the least amount of product. An excess reactant or excess reagent is any reactant that is more than what we need. So just like with the pizzas, we had more than enough crust and more than enough cheese. We had that left over after we made our 3 pizzas. Okay, so let's look at some ideas. To determine the limiting excess, there's going to be a few steps. The first one is you're going to have to complete 2 stoichiometry problems, 1 for each reactant. We will usually not give you more than 2 reactants. Then you're going to need to figure out how much product each reactant makes. And then the one that makes the least amount of product is your limited reagent. And luckily, on your worksheet, we're only dealing with moles. On this lecture, I will even show you grams. Okay, so let's look at a problem. So here on example 1, there is our balanced equation. Yes, you are going to need to still know how to balance an equation, see why we learned it. So it says if 2.78 moles of nitrogen oxide and 12.67 moles of hydrogen are put into a container, how much ammonium can theoretically be produced? This is all on theory. Nothing is perfect. You won't make this much. You may make more. We don't know. It's just theoretical, okay? So we're going to have 2 givens. We have one given of 2.87 moles of nitrogen oxide, and we have another given of 12.67 moles of hydrogen. Remember, we can compare amounts of different molecules when they're in moles, not when they're in grams. In grams, they're going to take up different amounts of space, which is why it's their mass, but in moles, it's about the number of atoms, and we can compare them directly for greater and least, okay? So here's our 2 givens, 2.87 moles of nitrogen oxide, but it wants to know how much ammonium it makes. So we must use our molar ratio here from our chemical equation to change moles of nitrogen oxide to moles of ammonium. And here, 12.67 moles of hydrogen, we'll use our mole ratio from our balanced equation here to convert from moles of hydrogen to moles of ammonia. So now at the top, the moles of a nitrogen oxide cancel out. Divide by anything on the bottom, multiply by anything on the top, and you will get 2.87 moles of ammonium. The moles of hydrogen here will cancel out. Go ahead and divide by what's on bottom, multiply what's on top. You will get 5.7 moles of ammonia. Now we have to look, what is my limiting reagent? What makes the least amount of product? Well, it's going to be right there. 2.87 is less than 5.07. So my limiting reagent will be our, if we look back, nitrogen oxide. And our excess will be hydrogen. Let's look at another example. So there's our balanced equation. What is a limiting reagent when 80 grams of copper reacts with 25 grams of sulfide? Now notice we have two givens. We're going to need two problems to set up. Also, we're in grams, which means we need our molar mass. So you go ahead and you can calculate your molar mass of copper and your molar mass of sulfur. Luckily, those are easy to read. You can read them right off the periodic table. But you're going to need to identify the limiting reactant. And you can stop at moles because you can compare moles of one molecule to moles of another. So if we start with 80 grams of copper, we need to convert it to moles. So we're going to use its molar mass. And our grams of copper are going to cancel. We're going to be left with moles of copper. Then we need to use our mole ratio from our balanced equation. And it's 2 moles of copper to 1 mole of copper sulfide. Our moles of copper will cancel to leave moles of copper sulfide. And you divide by anything on the bottom, multiply by anything on the top, and you'll get 0.629 moles of copper sulfide. That is for copper. Now we need to go back and figure out for sulfur. So we'll start with our next given, 25 grams of sulfur. We'll use the molar mass, 32.1 grams of sulfur to 1 mole of sulfur. Grams of sulfur will cancel. We now will use our mole ratio, which is 1 mole of sulfur to 1 mole of copper sulfide. 1 mole of sulfur, 1 mole of copper sulfide from our balanced equation. The moles of sulfur will cancel, and I will be left with 0.779 moles of copper sulfide. Then I can look at these two numbers, and the one that is least is my limiting reagent. So the one that is my limiting reagent is 0.629. It is lower. That is my limiting reagent, and we're done. Okay, so once you get to moles, if you're just identifying the limiting reagent, you're done. Once you convert both of them to moles of the product, then you can figure out what the limiting one is. Let's look at another one. So we have 1 mole of nitrogen plus 3 moles of hydrogen yields 2 moles of ammonia. So what mass means grams, mass of ammonia can be produced from 100 grams of nitrogen and 500 grams of hydrogen. We have two givens. We're going to have two stoichiometry problems to do. So we're going to start with our first given, and notice we're starting with grams, and we're going to figure out which one, and we want to go all the way to grams, okay? Grams of ammonia. So our first given is 100 grams of nitrogen. Then we're going to use our molar mass to convert it to moles, okay? And that's 28.02 grams of nitrogen to 1 mole of nitrogen. The grams of nitrogen will cancel. Then we're going to go from moles of nitrogen to moles of ammonia. So we need to do our molar ratio, which is from our periodic table, our balanced equation. 1 mole of nitrogen to 2 moles of ammonium. The moles of nitrogen will cancel to leave moles of ammonia, but it asked here mass. So we might as well go ahead and just convert all the way to mass. So we'll use the molar mass. Remember when we did our 3 steps, when we went from mass to mass, we're going to have to do the molar mass of both of our molecules that we're converting to. So then 1 mole of ammonium is 17.04 grams of ammonium. That is from periodic table. The moles will cancel. You go ahead, you divide by anything on the bottom, multiply by anything on top, and you would get 122 grams of ammonia. Now we need to go to our next given, which is our 500 grams of hydrogen. You will convert it to moles with its molar mass. Grams of hydrogen will cancel. Now we have moles of hydrogen, but we need to get to moles of ammonia, so we'll use our molar ratio from our balanced equation. And there's 3 moles of hydrogen to 2 moles of ammonia. Moles of hydrogen will cancel, but it wanted mass of ammonia. So we'll go ahead and use our molar mass of ammonia to convert it to grams, which is 17.04. Moles of ammonia will cancel to leave us grams of ammonia, which is what we're looking for. And you divide by anything on bottom, multiply by anything on top, and you'll get 2,810 grams of ammonium. The one that is least, because now we can compare grams to grams because we're in the same molecule, okay? So now which one is the least? 122. That is my limiting reactant, okay? Let's look at, I believe we have one more. So there's our balanced equation again. And it says, what mass of ammonia will be produced from 100 grams of nitrogen and 500 grams of hydrogen? So we know, because we're going to determine now the amount of the excess. If you remember from our last one, ammonia, or nitrogen, was our limiting, but look at all this hydrogen. We had made a ton of ammonia, so this is our excess. So we're going to figure out how much of that excess will we have left, okay? So from before, we know that 122 grams of ammonia can be produced, and nitrogen is the limiting reactant, okay? You then convert the amount of ammonia that is produced back into the excess reactant hydrogen. So what the heck does that mean? Well, remember, just like in the pizza, we could only make 3 pizzas. You have to start with where you can make. So the most we'll be able to make at this point is 122 grams of ammonia. So now we're going to start there. And this is determining how much of hydrogen is going to be left, okay? So we're going to start with our 122 grams of ammonia. We know that's the most ammonia we can ever make at this point. That's all we can make. Even we're going to have all this hydrogen left, but there's no nitrogen there to react with it, okay? So now we have grams of ammonia, and luckily we've already calculated the molar mass. So we got to convert it back to moles, okay, because we cannot go from one molecule to another without a mole ratio. So we'll use the molar mass of ammonia again, and grams of ammonia are canceled and will be in moles of ammonia. Then we can use our mole ratio from our balanced equation to go from moles of ammonia to moles of hydrogen. Our moles of ammonia will cancel to leave moles of hydrogen, but notice we have grams here, so we really need to go back to grams. I cannot subtract moles from grams. So then we're going to use our molar mass, 2.02 grams of hydrogen per 1 mole of hydrogen. Our moles of hydrogen will cancel to leave grams of hydrogen. Then we'll go ahead, divide by anything on bottom, multiply by anything on top, and we will use up. Notice, to make 122 grams of ammonia, we're only needing 21.7 grams of hydrogen. Now, it is asking us how much hydrogen is left then. Well, we started with 500 grams, and we're going to use up 21.7 grams. So to figure out how much is left, we're going to subtract it. 500 minus 21.7 is going to give us 478.3 grams of hydrogen left over. Now, okay, let's look at our worksheet. You have 4 problems on there, and we left it all in moles. You're not going to deal with this grams. I know I showed it to you, and your head might hurt a little bit, but actually on your homework, you're just going to go ahead and you are going to do it only in moles. So very exciting. Okay, so let's go ahead and look at number 1. I'll do number 1 for you, and then you guys will be on your own. So this is your limiting stoichiometry worksheet. Okay, and number 1, it gives us our equation, 2 aluminum plus 6 hydrogen bromides yields 2 aluminum bromides plus 3 hydrogen. So it says when 3.22 moles of aluminum, so that's one of my givens, reacts with 4.6 moles of hydrogen bromide, how many moles of hydrogen are formed? So it wants to know moles of hydrogen. So if we start with, and thank goodness we're leaving in moles, right? We don't have to worry about molar mass. So we're going to have 3.22 moles of aluminum. And we want to go to moles of hydrogen. And we're going to need our molar ratio here because we're starting with moles. So we have moles of aluminum here. And we have 2. And we want to go to hydrogen. Moles of hydrogen, 3. So it'd be 3.22. Okay. 3.22 divided by 2 times 3. This will give me 4.83 moles of hydrogen because moles of aluminum will cancel. Then we need to do our other one to determine how many we'll make from 4.96 moles of hydrogen bromide. So we'll do 4.96 moles of hydrogen bromide times 6 moles, because we have moles of hydrogen bromide is what we have, and we want to go to moles of hydrogen. That's what we want. It's going to go outside my box, but my moles of hydrogen bromide will cancel. Then I will take 4.96 divided by 6 times 3, and I will get 2.48 moles of hydrogen. Okay, so that's how much each one makes. Then my B question is, what is the limiting reactant? Well, it's going to be the one that makes the least. So which is smaller, 4.83 or 2.48? I'm really hoping you're saying 2.48. So our limiting reactant is going to be, if we look back, is hydrogen bromide. So it's HBr. And then for the reactant in excess, how many moles are left over at the end of the reaction? Luckily, because we're going just staying in moles, we don't have to do any conversions right now, because we know from here, this is our limiting reactant, this is our excess reactant, right? We are going to have to do just a molar ratio conversion, but not with all those grams. So we know that the most we get to make is 2.48. So that we start with the most that we can make of our product, which is 2.48 moles of hydrogen. And now we need to figure out, well, how many moles of aluminum am I going to use up making 2.48? Because I'm not going to make 4.83 because I can't once I run out of my hydrogen bromide. So then we convert that to moles of aluminum. So now we have moles of hydrogen, which is 3, 2 moles of aluminum, which is 2. So now we have 2.48. My moles of hydrogen will cancel. Divided by 3 times 2 would get me, I'm going to round it, 1.65 moles of aluminum are used. So then I will take, well, what did I start with? 3.22 minus 1.65. I will have 1.57 moles of aluminum left. So what I'm hoping is this helped. Luckily, this whole worksheet, it's only 4, and you're just going to stay in moles, and you're not going to worry about grams. It's not going to be on the test. It'll stay in moles. So if you don't understand it, please get a hold of me. I am more than happy to help you guys out and give you some more practice. Have a great day.